Okay, I want to go over 1 and 2 step inequalities. You're going to do it on Khan Academy, but I feel like the videos there are not as clearly set out as I want, and they teach this in problems with fractions and decimals, which is not acceptable for me. So let's look at the 1-step equations in inequalities. Now that you have done 1 and 2 step equations or 1-step equations, you understand that you understand how to work on both sides. Okay, so when you do these inequalities, you're assuming that the sides are equal. That's how you're solving these. So if where I have in the first one, x plus 3 is greater than 4, I'm doing the same thing. It's the same process as if it was an equation. What I'm doing is I'm going to take 3 away from both sides because I want to balance it out. I still want to balance it out, even though it's an inequality. Okay, and I'm going to get x has to be greater than 1. Okay, and if I, again, do my check, that means that I have 1 plus something greater than 1 is going to have to be, so 1 plus 3 equals 4. But I need something greater than 1, right? Because this says x has to be greater than 1. So, well, 2. 2 is plus 3 is greater than 4. So you know what, that is true. I need to have something greater than 1 to add to 3 to have it greater than 4. Okay, so I could have other numbers. 1 plus, I want to keep this down. 1 plus 3 equals 4, but I need something that's greater than. So anything greater than 1, if I put it into that inequality, it is going to be true. All right, let's look at the next one. In this one, we have a 1-step with multiplication. So I have 2x equals, 2x is greater than 26. Well, just like I do in an equation, I divide by 2. X is greater than 13. X has to be greater than 13. So same process. Okay, because I know that, the idea of moving to the inequality often confuses people. I'm going to go to and I know if I look up here and I put 13 in, 2 times 13 equals 26, but anything greater, if x is greater than 13, it will be greater than 26. Okay, let's look back down here. 2 steps. Same thing. I'm going to do the same thing I did in the equations. Minus 1. 2x is less than or equal to 8. Now I'm going to get rid of I'm going to undo the times 2 by dividing by 2 using the inverse operation. I continue to use the same language so you understand. So 4 can be less than or equal to, that x can be less than or equal to 4. Okay, and if I put 4 back in the equation, I have 2 times 4 plus 1, okay, and that could be equal to 9, or if I have something less than 4, it would be less than 9, like 3. 2 times 3, okay, plus 1 is going to be less than 9 because it's going to be 7. So anything less than 4 is going to be less than or equal to 9 in the equation. And on the other side, same thing. I just wanted to, in this next one, I want to show you that, because I have a habit of where I put things, and I want you to understand that. Notice that the equation is on the right side, and here is on the left side. It does not make any difference. It doesn't make a difference, but there usually is personal preference. Okay, so here I'm going to start solving this, getting that x alone. I take away 6 from both sides, okay, and so now I have 6 is greater than or equal to 3x. I need to get rid of that 3 times 3. Undoing times 3 is dividing by 3. and I have 2 is going to be greater than or equal to x. And so there you go. Okay, I mean, that's, it's the same exact process, no different. However, here's where the glitch is, okay, the difference. There is a special case with inequalities. There's a special case. And so I want to show that because there's no way you will get these right if you come to this situation. Notice that in this problem, negative 3x is greater than 18, that the x is negative. If the x is negative, you have to divide by a negative, okay, to get the answer, to solve for just x, you're going to have to flip the sign. So this, if I divide this by negative 3, which I would, right? I'm dividing both sides by negative 3, because negative 3 divided by negative 3 is 1. The answer to this problem is x is less than negative 6. Notice that I've flipped the sign. And even if it's equal to, it's the same thing. The equal to stays. But the greater than turns into a less than. That is absolutely essential for you to use to get the problems in the con correct and for you to understand inequalities. There is a proof for this, and if we have time, we can do that. But the down and dirty is that if I'm dividing or multiplying by a negative number to get the x alone, that I need to flip the sign, flip the greater than less than sign. Now, look at the problem below it. Is the x negative? No, it is not. It is not. If I divide this by 4 and this by 4, the answer is x is less than negative 3. Notice I'm not flipping the sign. I'm not flipping it. It's the same sign. It's the same sign. Same sign. Same sign. It's only if what I'm doing to get the x positive, okay, if the coefficient attached to the x is negative. If the coefficient, like it is here, the coefficient is negative 3. If the coefficient being multiplied or divided by the x is negative, that is the only special case where you flip the sign. I did not flip the sign in the second one because the x was already positive. It was 4x.